Howdy, partner. I'm Andrew. Today I'd like to teach you how to write an equation for a rational function with these characteristics. It has a vertical asymptote at x is equal to 3, a double zero at x is equal to 1, and a y-intercept at 4. So remember, a rational function is simply some function where you have a polynomial in the numerator, some function of x, and then some different function of x in the denominator. Okay, you have a numerator and a denominator. So what we're going to do first is we're going to focus on the vertical asymptote, and anytime you're focusing on the vertical asymptote, you're focusing on then the function of the denominator. And the reason being is because all vertical asymptotes arise from x values that give the overall function an undefined answer. The only thing that can make this undefined at the moment, I'm assuming no square roots or any craziness, is if there is a 0 in the denominator. Okay? Right? You cannot divide by 0. So what we're going to do is we're going to create a simple expression. Very simple. All you're going to do is do x, and then whatever this is, if it's a positive 3, just do minus 3. And that's it. Right? Because if x is 3 here and you plug in 3, what does this result become? 0. That's the point. Right? That denominator becomes 0, and you cannot then divide by 0. It becomes undefined. So that's a vertical asymptote. Next, we're going to take a look at the double zeros, or otherwise known as the x-intercepts. All right. So when you have a double zero here, we're going to treat it the same way. In other words, what this is telling us is that when x is 1, the function's value is now 0. So it is a real number. It is a real value. Okay. And what will make this function, or I should say, what will make this function become 0? Well, if the numerator is 0. So it turns out that I'm going to use the same exact logic. Right? So you have a double 0, meaning you have basically two factors up here. Okay, two factors. So if x is 1, you're just going to do x minus 1, x minus 1. Boom, done. Nice and simple. Last but not least, you're going to look at your y-intercept. So the y-intercept here, all y-intercepts have an x value of 0. All right, and then because that defines the y-intercept, right? And then the y value is going to be a 4. So what I'm going to do is take the 4, plug it in for my y value, or my f of x, then take the x value and plug it in for every x that I have in my formula. You do this at the end, by the way. You can't start with this because otherwise you'd have nothing to plug in, right? So you end with that. So it's going to be 0 minus 1 times 0 minus 1 all over then 0 minus 3. And this is then 4 equals, right, this is negative 1 times negative 1, that's a positive 1. 1 over then negative 3. Okay, and, oh, what? 4 equals negative 1/3? Shoot, I did something wrong. Just kidding. I didn't do anything wrong, all right? I'm showing you, though, that we need to add something. And when I say add something, I don't mean actually physically in the mathematical sense of add. We need to place in a coefficient, okay? We have to solve for a coefficient because there must be some constant here. There must be some constant that will make this equation work, because right now it doesn't make any sense. All right? So when you're doing the y-intercept, all you're going to do, plug in your y value, plug in your x value, and also put in a constant. Now you're solving for this. Okay, so how do we do that? Well, we simply multiply by the reciprocal, right? So that whole side would cancel. Whatever you do to the right, you got to do to the left. So it's negative 3 over 1. And that just works out to be negative 12. And that's your constant. So go back then to your original equation and just make that adjustment. In other words, you can write now your answer like this. Negative 12 times x minus 1 all over x minus 3. And that's an answer. You might have to FOIL the top. I don't know, but you can do that, right? It's just negative 12. Then the top should become x squared minus 2x plus 1 all over then x minus 3. And that's that. That's the answer, okay? That's your f of x. That's your rational function. You can also use the calculator to check. Watch, plug in negative 12 times. I'll do a double parenthesis to make sure I input everything properly. Everything property. So x squared minus 2x plus 1 divided by, this is x minus 3. Close those parentheses. And here's now the graph. So this isn't really, I mean, it's good enough, right? I'm not going to adjust the window. So what we have here now is, notice that it tells us we have a double zero at 1, meaning that's where the function just touches 1. There it is, right? Beautiful thing. It also tells us that the y-intercept has a -4. Look, there it is. Another beautiful thing. It reminds me of my math teacher, by the way. My 9th grade math teacher, and then she actually turned out to be my 12th grade math teacher too. She always used to say, it's a beautiful thing. And I remember in class, I'm like, just shut up. Oh my, it's not beautiful. Now here I am saying it. So if you're telling me to shut up, I agree with you. I'll try not to say that anymore. It's a beautiful thing. Ha, gotcha. So then there's a vertical asymptote at x is equal to 3, right? So if you were to go out to 3 here, there's going to be some vertical asymptote, and you can kind of see that this function, it's going up, but it's never going to quite touch, okay, that 3. And that's our function. That's it, ladies and gentlemen. So listen, thank you very much. I really do appreciate it. Thanks so much for watching. I do hope this video helps. And by the way, we have thousands of videos out there for you. Not only in math, but physics and chemistry as well. We have a lot more coming. We really want to help you through your class. All right, and the best way to practice is to do actual problems. And that's what we solve. Problems. Take care.